Welcome back to Math is Easy, Part 8 video. Hey, let's just get right into it. We're going to set up the problem, label our right triangle, and organize the values, A, B, C values. And here we have the formula we'll be using in order to solve and find the missing value of the leg length A. Let's jump right on in here to it. Let's get to it, Pruitt, my old grandpappy used to say. All right, so let's revisit our right triangle. So we have leg A, which we don't know the length of leg A. We have leg B, indicated in that part 1 video of the problem. One of the legs equals 4, and I've determined that leg B will equal 4. And we know C, the hypotenuse, which is always the longest length opposite that right angle of 90 degrees, is 5. That was also given in the problem. So we know that A is missing. We don't know what that is. That is our variable, X, Y, Z. In this case, it's going to be A squared. We don't know what the A value is, right? And so, well, the variable here is A, right? It's A. We want to solve for A. Get A all by itself in order to answer this question. The length of leg A. This particular side of the triangle. All right, and B is 4 and C is 5. So knowing these particular values, everywhere I see B in the formula, I'm going to substitute 4. Everywhere I see C in the formula, I'm going to substitute a 5. And then I'm going to simplify using some of those prerequisite skills I went over in parts 3, 4, 5, 6, and 7. So it's super important you understand those prerequisite skills. So let's just jump right into it. Let's start substituting values into the formula. All right, so step 1, again, substitute your values into the formula. We know that B is 4, so I'm going to substitute a 4 where I see B. I know my C, which is always the hypotenuse, is 5, so I'll substitute a 5 for C. Now you can start to see the equation. Now you want to get A all by itself. You want to solve for A because that is the missing value. Now, A is attached. Let me show you because we're going to use what's called inverse operations or the opposite, right? Everything on the left side of the equal sign we need to get rid of except the A, right? So the positive 4 raised to the second power. We need to get rid of that. We need to move it to the other side of the equal sign, right? And this power of 2 we need to get rid of. The only way to do that is to use inverse operations. The inverse of anything to the second power is the square root. So let me show you in these next coming steps what to do. So step 2 is to follow the order of operation. Let me show you that now. All right, step 2, follow order of operation or PEMDAS, right? Parentheses, P, are first. You simplify inside the parentheses first. Then you simplify your exponents. Then you will multiply or divide. And finally, you will add or subtract. Let's see this PEMDAS in action. All right, so you want to follow PEMDAS. You want to look here after we substituted the values for B and C, and you want to start with parentheses. Is there any parentheses? Well, yeah, we have 2 parentheses, but really what this is saying with parentheses is to simplify inside the parentheses. Are there any operations we can do inside the parentheses? No. So then we move on to the second, exponents. Can we simplify any exponents in this equation? Why, yes, we can. So that's what we're going to do next. Okay, so in simplifying the exponents, 4 to the second power is 4 times 4. 5 to the second power is 5 times 5. So I just rewrite my a to the second power because I haven't done anything with it. I rewrite the plus, I rewrite the equal sign. Now I'm going to, again, follow the order of operations. Are there any parentheses? No. Are there any exponents I can simplify? Well, there's an exponent here, but I cannot really simplify it with an a value, right? I guess a to the second power means a times a, but I'm not doing much, so I'm just going to leave that alone for now. All right, are there any, can I multiply or divide? Yes, I can multiply 4 times 4 and 5 times 5. What is 4 times 4? What is 5 times 5? All right. If you said 4 times 4 is 16 and 5 times 5 is 25, hot diggity dog, you're getting it done. Great job. So all I'm going to do is rewrite that a squared, rewrite the plus, equals, and then everything else is taking care of itself. Now, again, order of operations, I'm going to ask myself, are there any parentheses? No. Are there any exponents that I could simplify? No. Can I multiply, divide, add, or subtract? Yes. Right? I want to get a, again, all by itself. Okay? And so that means I got to get rid of this power of 2, and I've got to get rid of this positive 16. What is the opposite of a positive 16? That's right. An opposite of a positive 16 is a negative 16. But I just can't subtract 16 from one side. What I do on the left side of the equal sign, I gotta do it on the right side as well. So a positive 16 plus a negative 16, or 16 minus 16 is 0. I'm left with a squared. I'm just going to bring that down. I'll bring down my equal sign. What's 25 minus 16? All right, so if you said 9, you're absolutely correct. 25 minus 16 is 9. I bring down the equal sign. I'm bringing down my a to the second power. Now, my whole goal was to get a all by itself, which means it's still attached to that power of 2, or a to the second power. Now, I'm making a little asterisk here because I wanted to share with you the inverse operation, or the opposite of a power of 2, is a square root, right? I want to make this little asterisk. So to free the squared a value by using the inverse operation, which is the square root, to both sides, right? So if I square root the a squared on the left side of the equal sign, I have to put a square root around 9 on the right side of the equal sign as well. I have to balance my equation. All right, so a squared means a times a inside the radical. And I know 9 is 3 times 3 inside the radical. So I have a perfect pair of a's. I can pull out one value of a. You see that here, leg a equals, I have a perfect pair of 3's. That means I can pull out and free up a 3 from the radical. A equals 3. So your answer is going to be B. We have leg A equals 3, leg B equals 4. The hypotenuse is 5. Stick around for part 9 video. I'm going to show you how to check your answers to make sure you have absolutely gotten this correct. Thank you for joining me. Stick around. Part 9 video. Math's easy. Take step by step. Like, follow, share, subscribe. If I've helped you, please help me to help others.